Today I will talk about wiring on PCB. It's a fuse line that looks like this. Of course, there are linear, diamond, snake, and so on. Whatever it looks like, as long as it's a wire that acts as a fuse. Unified cold fuse wiring, because of its small size, low cost. Therefore, it is often used in low-power civilian products, such as switching power supply, charger, etc. I don't know if you've ever bought a cheap charger and then blow up the experience. It's mostly that kind of wiring, not a fuse. You might ask, why did it blow up? As a fuse wire is used for overcurrent protection. When current overload, the wiring will melt and form a short circuit that acts as a fuse. This route has a fatal drawback. It's just very low accuracy. This represents the overload current of the fuse wiring itself. There may be a mismatch between the overload current and the total circuit. So there are two very bad outcomes. First, the wiring does not fuse as expected. Then the other ion exploded during. Second, after the current the fuse blew with the bottom plate. Although FRC is fire resistant, but it burns under constant heat, and it cogs to the point where it can pass through a large current. Burned. Some of the wiring is for grounding and it all the way to the underworld. Of course, control the normal application. It can definitely train the professional ability of normally engineers. It's a blown fuse and you just need to replace it. But the wiring of this fuse is different. Once it's blown, it's basically irreparable. I know a lot of witty boys. I'm ready to put the fly line on the public screen. Then please look at the different types of wire fuse conditions compared with snake-like the straight lines are easy to work for longer distances. It's also easier to respond to the curved shape of the heat distribution if the load for a long time may lead to local laminate fire. The wider the route, the larger the load current. But very special is the narrow track cooling because a narrow trace can better distribute heat to the dielectric outside the trace. A wide line is therefore more likely to burn the covered wire. Is more likely than the bare wire to be catastrophically damaged in the continuous high current and width are controlled according to the characteristics of their own circuits. Line solution, unless you can perfectly calculate and control the thickness and curvature of the fly line, might end up looking like this. You, on the other hand, are more likely to be like this. So there is a risk of flying lines. So the repair board needs to be careful.